Hello everyone, welcome to Learn ReactJS for Front-End Development by CodeChef. In today's lesson, we'll be looking at the concept, the spectrum of components in React. When working with React applications, not all components are the same. Some are small and highly reusable like buttons, whereas others are large and more specific like entire pages. Instead of forcing these components into strict categories, it's easier to think of them as a spectrum, from small, flexible pieces to large purpose-built components. Understanding this concept allows you to write cleaner code and allows you to organize your components in a way that it scales naturally when your application grows. So in this lesson, we'll be looking at this concept step by step and understanding it with the help of a practical example. So let's begin. This lesson explains how React components differ in responsibility and reusability. By understanding these concepts first, the code we write later will feel logical and not confusing. So by now you would know about what a React component is. A component is a reusable unit of the user interface. It encapsulates structure, behavior, and styling. Large React applications are built by composing many components together. Now, components don't fit into strict categories. They exist on a spectrum, from small and reusable to large and specific. Where a component sits depends on its responsibility. In real applications, components evolve. Rigid labels don't adapt well to change. Thinking in terms of a spectrum helps keep design practical. So let us now look at small components, medium components, and large components. Small components focus on a single responsibility. They are highly reusable and contain little to no business logic. Medium components provide structure. They combine small components and accept content and actions via props. Large components represent pages or major sections. They compose smaller components and define page-specific behavior. So what makes a component reusable? Reusable components avoid hard-coded assumptions. They accept data and behavior via props and do not control intent. Reusability is about responsibility. Reusable components manage structure. Specific components manage behavior. As components grow and become more reusable, they accept more props. Manually handling each prop quickly becomes repetitive. Now let us look at prop delegation. Prop delegation means handling only the props you need and forwarding the rest. This makes components flexible and future-proof. This approach prevents constant refactoring and keeps component APIs clean. When both component and user define the same prop, a conflict occurs. If unmanaged, this can break behavior. The order of props decides which value wins. Some props override values while others must be merged. Now let us look at why refs exist. Some interactions require direct DOM access like focusing inputs. Refs exist for these imperative use cases. Refs work on native elements by default. They do not automatically work on custom components. So why is ref.current null? React does not know which DOM element to attach the ref to, so refs must be explicitly forwarded. React.forwardRef allows a component to receive and forward a ref to the DOM element. This keeps abstractions safe while enabling DOM access. In React 18, forward ref is required. React 19 simplifies this, but version awareness is important. Now that we understand what the component spectrum is, let's look at how this idea appears in real React code. We'll start with a reusable component and then see how it's used inside a more specific page component. Now let's begin with the card.jsx file here. This card component sits in the middle of the component spectrum. It's not as small as a button and it's not as specific as a page. We first import React and the button component. This immediately shows that the card itself is built using smaller reusable components. The card accepts three props: title, content, and action buttons. These props make the component flexible instead of tied to a single use case. Inside the JSX, we render the title inside an h2, the content inside a paragraph, and a container for actions using card actions. The important part here is action buttons. Instead of deciding what buttons to render, the card simply renders whatever is passed to it. Now this is what makes the card reusable. The card does not decide what the buttons do, how many buttons are there, or what text they display. All of those decisions are pushed to the parent component. The card only handles layout and structure. Now coming to the homepage.jsx, the homepage is a large specific component and it represents a single screen in the application. At the top, we import the card and button components along with the CSS. This shows how larger components are composed from smaller ones. Inside the homepage, we define two functions, handle learn more and handle subscribe. This logic belongs in the page component because it's specific to the screen. Reusable components like card and button should not contain this kind of behavior. In the JSX, we render a title and then use the card component. We pass a title, a content string, and for action buttons we pass 2 button components. Each button is reusable, but the actions are decided by the home page. This structure clearly demonstrates the component spectrum. The button is small and highly reusable. The card is medium-sized and reusable with structure. The home page is large and specific. It brings everything together. So why does this approach scale? Instead of creating new components for every variation, we reuse existing ones and customize them using props. This avoids duplication and keeps the codebase clean as the application grows. A useful way to think about this is, reusable components control layout while specific components control behavior. This mindset helps you design components that scale naturally. You can review how data and behavior flow through these components. Try changing the content or buttons and observe how the card remains reusable. Once you are comfortable with the flow, you can submit the solution and move on to the next problem. Up to now, we've been passing props explicitly to our components, and that works fine when a component supports only a few props. But as components become more reusable, this approach starts to break down. Let's start by looking at the current implementation of the custom input component. This component explicitly lists every prop it expects: type, value, required, max length, and onChange. And each of these props is manually passed down to the input element. This works, but it does not scale. Every time we want to support a new input feature, like placeholder, area label, or a data attribute, we have to add it to the function parameters, pass it manually to the input, and modify this component again. This is repetitive, error-prone, and unnecessary, especially when the component itself isn't doing anything special with those props. What you really want is a way to say, I only care about a few props, and everything else should just be forwarded. This idea is called prop delegation. Now let's look at the updated version of the same component. Instead of listing every possible input related prop, we only destructure what the component actually uses, that is label and ID. All remaining props are collected into a single object called input props using the REST operator. The REST operator gathers all leftover props into one object. This includes type, value, required, onChange, and any future props we add later. The component doesn't need to know what they are, it just forwards them. Inside the JSX, we now spread input props directly onto the input element. This means any valid input attribute or event handler passed to custom input will automatically be applied to the input. No extra code is required. So how does this improve reusability? This makes custom input much more reusable. The component focuses only on rendering a label, generating a stable ID, and connecting the label to the input. All other behavior and configuration is delegated to the parent component. When this component is used elsewhere, we can freely add props like placeholder, area label, and data test ID, and they will just work. We don't need to update custom input again. A useful rule to remember is this: if a component doesn't actively use the prop, it shouldn't explicitly define it, it should delegate it. This solution makes the component simpler, more flexible, and easier to maintain, and it prepares the component for future requirements without additional changes. Once you've verified that extra props are being passed correctly, the solution is complete. In this task, we are working with a simple button component. The goal is not just to make it look good, but to make it safe, reusable, and predictable. We already have styles defined with the base button class and variations like button primary and button secondary. Our button component should always apply the base button class and then allow users to add their own classes for styling. Now in this line over here, the button is intended to always be a normal button with the type button. But because we are spreading other props after defining the type, a user can accidentally override it by passing type equal to submit. This can break behavior, especially inside forms. Now the second issue is with styling. In this particular line over here, if the user passes a class name, it completely replaces the base button class. That means we lose the fundamental button styling. What we actually want is always apply button and then use any user provided class. Now let's start with the class name problem. Now in this line over here, we manually combine the base class button with whatever class the user passes. The trim function ensures there are no extra spaces if class name is empty. Now let's look at how we fix the type conflict. In this particular line over here, the order is intentional and is very important. By spreading other props first and then explicitly setting type and class name, we ensure that our component's values always win. So even if the user passes type equal to submit, it gets ignored for the actual button type. Now coming to why this design is important. This is a good example of building safe component APIs. The component allows flexibility where it's safe, but protects critical behavior and enforces consistent styling through the base class. This uses ideas we've already learned: prop delegation using other props, prop conflicts and precedence, and manual merging of props like class name. The difference is that now we are applying them in a real production style component. Now here in the example usage, each example shows the behavior clearly. Default button gets BTN, primary button gets BTN, BTN primary, attempts to override type fails safely, and disabled still works correctly, all without changing the button component again. A good rule to remember is this: delegate freely but protect what matters. Let users customize appearance and behavior, but don't let them break the component's core purpose. With these changes, the button component is reusable, flexible, and safe by default. Once you have verified the behavior in all cases, the solution is complete. Up to now, we have learned how components sit on a spectrum and how to design reusable abstractions. Now we are going to look at a case where abstraction breaks something important: direct DOM access. Let's start in app.jsx. Here, we create a ref called usernameRef using useRefNull. Inside the use effect, we try to focus on the input field as soon as the component mounts. In React 18, this does not work. If we log usernameRef, we'll see that current is null. This is expected behavior. The ref is attached to a custom component called inputWithLabel and not directly to an input element. React does not automatically pass the refs through custom components. This component over here wraps an input with a label. It looks correct visually, but the ref never reaches the input label inside. At this point, React has no idea which DOM element inside this component should receive the ref. To fix this, we need to explicitly forward the ref. That's exactly what React.forwardRef is designed for. Now instead of defining a normal function component, we wrap it using React.forwardRef. The ref now becomes the second argument to the component. This is React giving us control over where the ref should go. In this line over here, we explicitly attach the ref to the input element. This tells React that when someone uses a ref on this component, give them access to this input. Now, when the component mounts, username ref.current points to the actual DOM node. The focus call now works as expected. This confirms that the ref is no longer null. This solution is required because we are using React 18. In React 19, refs can be passed like normal props, but that behavior does not apply here. The key idea to remember is this: refs talk to the DOM. Custom components are abstractions. If an abstraction blocks access, you must explicitly forward the ref. In some cases, you may also wrap a forward ref component with React.memo to avoid unnecessary re-renders. If you do that, the order matters: forward ref first, then memo. With this change, the component remains reusable but no longer blocks imperative access. Once you have confirmed the input focuses correctly, the solution is complete. So you can see if we run the code before applying the solution, we will get this error over here. Now let's look at how it looks when we apply the solution and run the code. So you can see after applying the solution, we do not get any such error. So that wraps up our lesson about the spectrum of components in React. To really understand this concept, make sure to head over to the CodeChef platform and try out the practice problems yourself. That's where the real learning happens. So that was it for this lesson, and I'll see you in the next one. Thank you.